In this section, we're talking circles and ellipses. The goals: number 1, to find the equation of a circle given its center and radius. Number 2, to find the center and radius of a circle given its equation. And number 3, we want to graph circles and ellipses. So let's get started. Circles come up a lot. Having the equation of a circle is useful. You can get it using the Pythagorean theorem or distance formula. It doesn't matter how you think of it. So the standard equation of a circle, let me show you just where it comes from. This will be good to know for both trig and any algebra class you go into, trigonometry and algebra. Let me just draw a circle. Does that look circular on your screen? Looks circular on my screen. Close enough, right? Okay, so let's say we have a circle. Do you guys remember what the definition of a circle is? I mean, you know what it is. It's round, right? but actually putting it into words, that's a little harder. Okay, every circle has a center. I'll try and get close to the center here. C for center, capital C. But the center is not part of the circle, right? The circle is the curve. When you're little, you think of the circle as being the curve in its inside, right? But the inside is really the area. The circle itself is just the part in red. It's the curve. So how do you get the curve? It's a set of points, isn't it? Yeah.
A set of points with equal distance to the center.
It's a set of all points. That's exactly right. It's a set of all points that are the same distance from the center. That's the that set of points in red there. So that means if I draw, let's say this point is kind of a generic XY out here. No matter where I put that XY, I put it there, but I could have put it here or anywhere. The distance from the center to any point XY on the circle, let's call it R. What does R stand for? Radius, yeah. Okay, now look. Let's draw in a right triangle that's going to help us find the equation of this circle. I'm going to draw it so that it has a horizontal side, like that, and then a vertical side, like that. You see the right triangle? Okay, now the center, we'll call the center HK, H comma K. So H and K are constant numbers. The center, for any circle, the center is not going to change. The X and Y can change. I could have drawn that point anywhere on the circle in red. Okay, so if you think about it, between the center point, HK, and the point XY on the circle, what's the run going to be? This horizontal distance I've drawn would be the run, right? The horizontal distance between HK and XY, what would that be? X minus H would be a good way to write it. And what would the rise be? Y minus K. What happens when you apply the Pythagorean theorem here? X minus H is the length of one leg, the horizontal leg. Y minus K is the length of the vertical leg. And then R is the length of the hypotenuse. What does the Pythagorean theorem tell us about the relationship between those quantities? You could take the run squared, X minus H squared, plus the rise squared, Y minus K squared, equals R squared. It's the same thing we did to get the distance formula. The difference is X and Y can vary. As long as X and Y is any point on that circle in red, this is true, according to the Pythagorean theorem. Hey, well wait, H and K is fixed, R is fixed. We've got an equation with two variables, X and Y. That's it, that must be the equation of a circle. And in fact, we call it the standard equation of a circle, that's it. And it's so important, you use it so often in math and geometry. Guess what you have to do? You got to memorize it, right? X minus H quantity squared plus Y minus K quantity squared equals R squared. Or just be able to draw the picture that I just drew and come up with it. Either or. I don't care. So the reason why it's called standard form is you can look at it and get the center. The first coordinate of the center is the thing you subtract from h. It's kind of like finding the first coordinate of the vertex. The first of a parabola. The first coordinate of the center is h. The second coordinate of the center is k. It's what you're subtracting from y. So that it's a lot like finding the first coordinate of a vertex of a parabola for the second coordinate as well. So the center is hk, c for center, and then of course r is equal to the radius. And any equation that is written in this standard form, you can immediately identify the center, hk, and the radius. Okay, so in this example, let's find the equation of a circle with the given center and radius. I recommend writing the equation down every time you use it. You'll have it memorized in no time. So just write it down. The standard equation is x minus h quantity squared plus y minus k quantity squared is equal to r squared. In this case, you're just filling it in. So what's h and what's k? They're both 0, aren't they? So what do you get on the left side when you fill those in? X minus 0 squared, am I going to write that? Isn't that the same as just x squared? Same with y minus k squared. Y minus 0 squared, I'm not going to write that. I'm just going to write y squared. And then what's r? 1, so 1 squared, but what's 1 squared? So, well, you know what? My inner monologue is telling me this is the first example. I shouldn't have done it that way. My little voice inside my head is telling me I should show you this, right? Yeah? But then how are you going to write it? You're not going to write x minus 0 squared. You're going to write x squared. And then y squared, and then 1 squared, or just 1, right? Okay. So x squared plus y squared equals 1. That's a very special circle. It's called the unit circle. The circle with center 0, 0 and radius 1 is called the unit circle. And if you're going into trigonometry, you need to be aware of this. It's called the unit circle. In other words, if you graph it on the xy plane, then it's just going to be the circle whose center is 0, 0. So here's the x-axis, here's the y-axis. The center is at 0, 0, and you're just going to go out to graph it. You would go out 1 unit to the right. The best way to graph a circle, if you're just doing a quick sketch by hand, is to just plot 4 points. Go out 1 radius to the right, 1 to the left, 1 radius up, 1 radius down. In this case, you're going to go out a direction or a distance of 1 left, right, up, down. And if you're just doing it by hand, it's not going to look perfect. It's hard to draw a perfect circle by hand. But you draw it something like that. So you plot the center, go out the distance of the radius in 4 directions, left, right, up, down, and then you have your graph. And in this case, that's the unit circle when the distance you're going out in all directions is 1. Okay, it turns out to be very important to define the trigonometric functions, the unit circle. So if you're going to take trig anytime in the future, just kind of keep that in mind. Unit circle.